Welcome to the second video lecture for Chapter 4. In this section, we will cover Newton's second law. Newton's second law is the relationship between the amount of force on an object with mass and the resulting subsequent acceleration of that object. More commonly, you've seen it in the form on the right side here. Force is equal to mass times acceleration. I like to view it as acceleration is equal to the force divided by the mass. In this case, it's kind of easier to see visually that a larger force will result in a greater acceleration, and a larger mass will result in a smaller acceleration. Notice here that it's the net force. That means it's the total forces acting on an object. The unit of force is the Newton. You should already hopefully have seen this before. In addition, the English system, the pound is the force. Interestingly enough, the unit of mass for the English system is the slug. Something not very commonly known and kind of interesting. Go ask your parents what the unit of mass is in the for America, and it's actually the slug. Most people outside of physicists will probably get that wrong. A free body diagram, or FBD, is a visual representation for all the forces acting on an object. It's important to draw it with a dot and the arrows connecting to the dot and moving in their respective directions. The AP exam graders will actually take points off if your arrows do not touch your dot. In this case here, we have two people pushing on a car, and we have a opposing force of friction, or sliding friction in this case. And we have the drawing here. We have a net force in the positive direction of 670 newtons. And then the overall or total net force would be 110 newtons to the right. You could leave that as just a positive 110 newtons, but you may also want to denote that as in the X or Y direction, which we will see in a second. As I've mentioned before, force is a vector quantity. Therefore, it can be split into components. In two dimensions, we have the X and Y component. Here below you see the equation with a sigma, that's the kind of crooked E, that means the sum or total. So the total force in the X direction is equal to the mass times the acceleration in the X direction. Remember also, acceleration is a vector quantity. So important when solving problems is first draw your free body diagram, then split up all your components into their X and Y direction, separate them out, find the net force in the X direction and the net force in the Y direction, and use those to find the acceleration and any subsequent questions. I hope this has been more of a review than a first time through. Thank you very much. Please make sure to come to class with any questions that you have. In addition, please watch video 7 for Chapter 4 for help solving problems. There's going to be a lot in there.